Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to it and hit the bell icon to get notified when I post my new videos. Today I'll be discussing regarding what are the various conditions of sway moments which are adopted while calculating or while analyzing the portal frame using moment distribution method. So basically what is a sway? So sway is nothing but it is a lateral displacement of joints in a portal frame due to unsymmetry in dimensions, loads, moment of inertia, and end conditions. I just repeated. Sway is the lateral displacement of joints in the portal frame due to unsymmetry in dimensions, loads, moment of inertia, and end conditions. So, in my previous lecture series, I had briefly discussed regarding what are the various situations where the sway occurs in a portal frame. So I just brief it out right now. So the first condition wherein the sway occurs in a portal frame is that when it is subjected to the unsymmetrical loading or eccentric loading. So second one is that when it is having the unsymmetry in geometry. So third one, different end conditions of the column. So fourth one, it is having non-uniform section of the members. Fifth is that unsymmetrical settlement of the supports. And the last is combination of all of the above. I repeat it once again. When the portal frame, when it is subjected to unsymmetrical loading. Second one, unsymmetry in geometry. So third one, different end conditions of the column. Fourth one, non-uniform section of the members. Fifth one, unsymmetrical settlement of the supports. And then last is that combination of all of the above. So coming on to this first concept of this lecture series is that what are the various cases to be adopted to calculate the sway moments. So basically, when a portal frame which has to be analyzed by moment distribution method. So first we are supposed to do the non-sway analysis of the portal frame by calculating the fixed end moments first. So after solving the I mean the moments for by using the non-sway analysis, some amount of additional moment which are generated by the sway of the portal frame will be analyzed by the sway analysis. So that sway moments will always depend on the type of the supports so type of the supports of the portal frame. So that conditions we are going to explain in this slide here. So the first case is that the when both the ends are fixed. So when both the ends are fixed, I just consider this portal frame here A, B, C, D, wherein A and D are the fixed ends. So A and D are the fixed ends. So AB is the column which is having length L1 and moment of inertia is equal to I1. So similarly, CD is the length of the column with the length is equal to L2 and moment of inertia is equal to I2. So you can just observe that this is a portal frame which is usually subjected to sway. Why? Because the column length are different and then the moment of inertia for the two columns are of different. So in this case, the additional moment due to the sway, apart from the moments which are generated by the non-sway analysis, are calculated in this condition as m is equal to minus 6 ei delta divided by l square. So additional moment due to sway when both the ends are fixed is equal to minus 6 ei delta divided by l square, wherein delta is nothing but the amount of sway, that is our amount of the displacement of the portal frame. So l is the length of the column member, and then E is the Young's modulus, and I is the moment of inertia for the respective column member. So when I just take the AB member, So for AB and BA, moment is equal to 6EI1 delta divided by L square, wherein in place of L, it is equal to L1, since the length of AB and BA is equal to L1. So in place of I, it is equal to I1. So therefore, the additional sway moment is equal to minus 6EI1 delta divided by L square. So similarly, for member CD is concerned, the moment is equal to MCD, that is equal to MDC, is equal to minus 6EI2 delta divided by L2 square, wherein I2 is the moment of inertia for CD, and L2 is a span distance for CD. So if I just take the ratio of sway moments, so at the column heads, so in such case MAB by MCD is equal to MBA by MDC. So if I just take the ratio of this sway moments, so I will get the moment as I1 L2 square divided by I2 L1 square, I1 L2 square divided by I2 L1 square. So this is the ratio of the sway moment for the column at the column heads when both the ends of the portal frame are fixed. So coming on to the next case is that case 2. Coming on to the next case, that is case 2, when both the ends are hinged. So when both the ends are hinged, the moment additional moment is equal to minus 3 ei delta divided by L2 square. So when both the ends of the portal frame are hinged, then moment additional sway moment is equal to minus 3 ei delta divided by L2 square, L square. So whenever MBA is concerned, MBA at AB span with BA of moment is concerned, with BA of the with moment of BA is concerned. So the moment additional moment for BA is equal to minus 3 ei1 delta divided by L1 square. So wherein I1 is the moment of inertia for BA and L1 is the length of BA. So similarly for CD, the additional moment is equal to minus 3 ei2 delta divided by L2 square. So if I just take the moment ratio of the additional moment at the column heads, so therefore it will be equal to I1 MBA by MCD is equal to I1 L2 square divided by I2 L1 square. So here you are supposed to make a note that since both the ends are hinged here, so at A and at D there is a presence of hinge support, wherein moment of AB and moment of DC is equal to 0 always whenever when the supports are hinged. So the respective moments from from the support as origin, the moment will be equal to 0. So therefore MAB and MDC is equal to 0. Only the occurring moment due to the additional sway condition will be MBA and MCD in this case. Okay. So next coming on to the next condition is that when one end is fixed and another end is hinged. So here you can just observe the portal frame here ABCD. So wherein A is fixed and D is the hinged support. So in such cases, so MAB is equal to MBA. So that is nothing but 6 EI delta divided by L1 square. So whenever in the previous slide we had studied when the end is fixed. So in such case, moment is equal to minus 6 ei delta divided by L square. But in this condition in particular, MAB will be equal to MBA. So the moment will be equal to minus 6 ei1 delta divided by L1 square. So similarly, mcd is equal to minus 3 ei2 delta divided by L2 square, because the span CD with the D as the hinged end, so moment will be equal to mcd, that is equal to minus 3 e I2 delta divided by L2 square. So as in the previous slide we had told that the moment with the support as hinged and with hinged as the origin, the moment is equal to 0. So therefore d moment at dc is equal to 0. So moment of a span with support as origin, when it is hinged, so in such cases the moment will be equal to 0, therefore mdc is equal to 0 in this condition. So whenever if I want to take the ratio of the additional moments at the column heads, so mba divided by mcd will be equal to 6 ei delta 6 ei1 delta divided by l1 square divided by 3 ei2 delta divided by l2 square. If I just solve that, I will get the value as 2 i1 l2 square divided by I2 L1 square. So this is the ratio of the additional moment at column head level when one end of the portal frame is fixed and one end is hinged. So the next concept here is to be adopted for is the procedure to be adopted for the sway analysis of a member is that, so first is the calculation of a fixed end moments, so second one is calculation of a distribution factor, so third is, as I said, that when a portal frame whenever they have given a portal frame in order to solve for a in order to analyze it, so when it is in a sway condition, so in such cases first we are going to solve with a non-sway condition by calculating the fixed end moments and finally the total moments. So apart from by calculating the fixed end moments and total moments due to the non-sway analysis, additional moments should be calculated due to the sway, so that is nothing but the non sway analysis. So first thing we are supposed to do as non-sway analysis. So next is finding what is the amount of sway force which are responsible for making the portal frame as the sway condition. So next is calculation of the sway moments based on the type of the support condition what we had studied in the previous slides. So the next is assuming the moments in a column. So after solving the sway moments, we are going to assume some amount of moment for a column. So after assuming that moment in a column, we are going to balance that moment by using the moment distribution table. So after balancing that moment, we are going to take make some corrections by using sway correction factor, so that the values of the moments will be balanced. Thank you for watching. Please like, share, and subscribe to my channel if you liked it. Thank you.